Here at the immense Nevada test site, an hour's drive north and east of Las Vegas, land was set aside by the government for testing the Tory reactors.
The area itself is the Nevada test site, which is a large part of the state of Nevada. And the Nevada test site is, of course, where the bombs were tested in the 50s into the early 60s.
The area for testing the Tory reactors was designated Site 401. The 8-square-mile test area was also referred to by the name of the desolate piece of land where it was built, Jackass Flats. Site 401 is comprised of a triangle of 3 building areas. The control area to the south, identified by its neighboring water tower, the test bunker to the north, and a disassembly building to the west. The control building is about 2 miles from the test bunker, and thousands of miles of cable connect the two, allowing remote control and observation of the reactor. To avoid human exposure to the hot reactor, a rail line connects the test stand to the disassembly building. A radio-controlled locomotive moves the reactor to and from the test bunker.
When I got to this area 401, Jackass Flats, there wasn't anything there. We built a disassembly facility, which means very thick concrete walls and lead glass water-filled windows, so that we could do disassembly operations on Tory 2A and Tory 2C.
With all the hot cell restrictions of 6-foot thick concrete walls and remote handling capability to allow disassembly operations.
Then we had to build a little rail line from the disassembly building to the test bunker.
The Tory reactors were mounted on a rail car and pulled from the disassembly building to the test bunker by a battery-powered locomotive. Near the test bunker, the locomotive backed into the spur and then pushed the reactor to the face of the test bunker, where air supply and electrical control connections were made. After the test run, the reactor disconnected from the test bunker and was pulled back to the spur. Then it was pushed into the disassembly building, where it could be disassembled and examined remotely.
The reactors were assembled in the disassembly building and then carried with a shuttle train on about a 3-mile track to the test site. So you could pull a reactor along the traverse and then back it down to the zero site and connect it to the air source.
Once connected to the test bunker, the reactor was supplied with compressed air at 720 pounds per second at a temperature of 1,060 degrees. This simulated the ram air temperature and pressure found in Mark III flight. The stored air was heated in these tanks by an oil-fired furnace. Miles of oil well casing stored 120,000 pounds of air at 3,600 pounds per square inch. Enough air to test the Tory 2A at full power for 90 seconds.
The tank farm that stored the air for the blowdowns consisted of many, many long sections of oil well casing, 10-inch nominal or something like that. And it laid out on the ground in a couple of acres or so, and it would take days for the compressors to compress the air. So it was a big operation just to get enough air.
We had most of the welders on the West Coast working around the clock at the 401 site to meet our time schedule.
Lawrence Livermore borrowed giant air compressors from the Navy's submarine base in Groton, Connecticut, to fill the tank farm with compressed air. Pumping the tanks to capacity took around 2 days. Air leaving the tank farm first passed through the heat exchanger. The heat was retained in metal containers by millions of ball bearings.
We had 4 large containers that we filled with 1-inch diameter stainless steel balls to comprise a heat mass. When we got ready to do the test, we blew down the tank farm through these tanks full of hot stainless steel balls, and were able to achieve the temperature that we wanted to simulate the inlet conditions to the ramjet.
The whole thing was at such a scale and such complexity and expense and effort that their major concern was, will it work?
0-3 moving, or 0-1 moving.
All the work we did here was pointed towards one big final test. And so we had to do a lot of preliminary work. And we did cold blowdowns first through an empty test vehicle to test all the auxiliary equipment.
All right. How does it look now?
We would have the reactor at 0 power, and therefore it wasn't adding heat to the system. And we would just take air from our tank farm and blow it through the reactor to make sure the controls were working properly and that the temperature, the instrumentation was working properly.
Response is satisfactory. Very good. Internal operation control. Nuclear operator, increase nuclear power to a core temperature of 1900 degrees is reached.
After years of preparation at Site 401, several dry runs to test the entire system, and a 2-day delay because of unfavorable wind conditions, the first full-power test of the Tory 2A commenced on May 14, 1961.
Are you going up, nuclear operator?
The Tory 2A bird was to be supplied with ram air that would duplicate Mach 3 operation at sea level.
Programmer, start your program and announce progress.
Once the nuclear reaction is initiated, the wall temperature of the reactor increases rapidly to well above 2,000 degrees Fahrenheit.
2300. Very good.
The air leaving the reactor at the exit nozzle peaks at over 1,800 degrees Fahrenheit. For 45 seconds, the 2A runs at 50 megawatts, almost doubling the temperature of the airstream flowing into it.
All I saw mostly were dials and the backs of heads of several operators. So to me, the test consisted of television pictures, strip chart recorder lines, and then the final shutdown, and then a great relief.
3 additional full-power runs proved the design of the Tory 2A. However, the reactor had neither the power rating or a complete design to be used as a flight reactor. The reactor itself was air-cooled, but the reflector that contains the control rods were cooled by a 20,000-pound cooling system of the heavy water deuterium oxide. A reactor cooled only by the airstream of the ramjet would be needed to sustain flight for the missile and its payload. Plans to test a second reactor, the Tory 2C, with a power rating of 500 megawatts, were given a green light. Design for the Tory 2C reactor began in June of 1960. A reactor capable of propelling the PLUTO missile would need a larger core, with the reactor control rods operating within the core itself. Hydraulic actuators were used to position the control rods and control the criticality of the reactor. Without the heavy water cooling system, the actuators had to withstand temperatures of 1,200 degrees Fahrenheit.
When we went to the full-scale reactor in the Tory 2C program, we didn't have this large heavy water reflector because, of course, that wouldn't fly. And we had to operate without a big heavy water reflector, and we had essentially a flyable reactor in the Tory 2C reactor.
In the Tory 2C, the entire reactor was air-cooled. The fuel elements in the 2C were inspected for cracks, sorted according to their concentration of uranium, and bundled into